Welcome to AP Environmental Science. In this video, we are talking a little bit about food chains and food webs and what happens when a link within a food chain or food web is disruptive. Now, a food chain, this is a simple model of the passage of energy from one organism to another during the process of consuming or eating. This should be a bit of a review. You probably have seen a food chain before. Now, what I want you to remember, though, is the direction of the arrow. That's super important. So the arrow shows the direction of energy flow, and it points towards the organism that is doing the eating. I like to be able to turn these arrows into little Pacman, and that Pacman should line up with the arrow, and it should show that organism chomping away, eating the organism that's a little lower on the food chain. So in this instance, the grasshopper is eating the grass. The shrew is eating the grasshopper, and the owl is eating the shrew. So the little Pacman should line up with the arrows, and then you know that you have arrows drawn in the correct direction. A food web is just a slightly more complex model showing interconnected or interlocking food chains. Now, this diagram comes directly off of a released AP exam. There was a year where they asked students to identify a secondary consumer in this food web. But it also asked students some higher level questions to draw conclusions that would have resulted from disruptions in this food web. And that's what's called a trophic cascade. Now, trophic cascades are these powerful indirect interactions that can control entire ecosystems. And these often involve these unintended consequences at the lower trophic levels when you have some kind of disruption at the higher trophic levels. So on this diagram, the plus is showing a direct relationship. So as the elk increase, the wolf increase. The minus is showing an inverse relationship. So as the elk decrease, that arrow pointing to the aspen, that's a minus. So that means the aspen are going to increase, so it's an inverse relationship. Now, a trophic cascade would be if you have a disruption at this top level of the food web here. So what would happen if there were not any wolves? So if you look at the interaction between wolves and elk, well, the elk population would increase because if you have no wolves, so fewer wolves means more elk. You follow that minus arrow. But then what about the elk impact on aspen and willow? Well, if you have more elk, that means you're going to have less aspen and you will have less willow because again, that's a minus arrow. But what about beavers? So if you have fewer willow, what does that mean for beavers? Well, that's a direct relationship because you have the plus arrow. So fewer willow means fewer beavers. So having this change in the wolf population impacts the other levels. So we see changes beyond that between the wolves and their direct prey species. This also leads to what's called a feedback loop. And feedback loops play an important role in food chains, and they play an important role in a wide variety of environmental processes. We have what are called positive feedback loops. I like to think of these as change leads to more change. And we also have negative feedback loops, where change leads to less change, or we return back to equilibrium. These two terms will come back throughout the entire course. Just know positive feedback loop, if you have some kind of disruption, because of the process that it triggers, it leads to more disruption and things start to spiral out of control really quickly. With a negative feedback loop, things are returning back to that natural balance. So the interaction between the wolves and the elk, so just that little bit where you have more wolves, that means you have less elk. But then when there's fewer elk, that means that there's less food, so the wolf population will start to decrease as well. But then when you have less wolves, that means there's less predation on the elk, so the elk population can start to increase. Because this is change leading to less change, that means that this is an example of a negative feedback loop. In summary, food chains and food webs, these are just diagrams that are showing that transfer of energy between trophic levels. And if you disrupt these food chains and you disrupt these food webs, that can lead to the process of a trophic cascade. Please send me any questions or comments that you have about this video, and I'll get back to you as soon as possible. And I hope that as you watch this video, you were able to learn something.